A blower wheel is easy to ruin in the final 5 mm of removal. One hammer blow on the shaft, one pry bar against a blade, or a puller hooked to a thin side plate can turn a reusable wheel into a vibration problem. The safe method is not pull harder. It is to identify the hub connection, preserve the installed geometry, place the force through the strongest load path, and keep that force coaxial with the shaft. Start by identifying the assembly. A furnace or air handler blower may use a forward curved wheel inside a scroll housing. An industrial fan may use a backward curved or airfoil wheel with a separate inlet cone. Locate the hub, shaft, motor or bearing support, set screws, keyway, locking collar or taper bushing, and every panel that controls access. The 3 Longwell wheel views in this film are product anatomy references. They show the hub and side plates, not a removal procedure. Next, determine why the wheel is stuck. Common causes include a missed second set screw, a key still carrying load, corrosion between bore and shaft, a burr at the shaft end, a locking collar, a taper lock bushing, or a wheel that is already cocked. Do not assume every hub is a plain bore. Read the equipment manual and the hub or bushing markings before choosing a tool or direction of force. Before loosening anything, capture the geometry passport. Photograph the hub face, fasteners, key position, shaft projection, wheel rotation arrow and any balance weights. Measure wheel position from a rigid manufacturer-defined datum. For a scroll blower, record wheel centering inside the housing. For an industrial centrifugal fan, record inlet cone overlap, radial gap and axial alignment. These measurements make accurate reassembly possible. Now establish the safety boundary. Stop the equipment, isolate every electrical and mechanical energy source, apply the site lockout or tagout procedure, and verify de-energization before entering the wheel area. Control stored rotation and support heavy components. Capacitor, belt tension, elevated assemblies, and sharp sheet metal edges may create additional hazards. Work beyond your training or the manufacturer procedure belongs to a qualified technician. Create the access path specified for the exact unit. Remove guards, panels, inlet cone, blower deck, motor mount or shaft assembly only in the documented order. Support anything that can drop, rotate, or pull on wiring. Never gain clearance by bending a blade, side plate, or housing lip. Green hex service information, for example, requires alignment and inlet geometry to be restored after disassembly. Dakin instructions call for the wheel to be centered in its housing during reassembly. At the hub, clean dirt from each fastener and confirm the tool fully seats. Remove every set screw, key retainer, locking screw or bushing fastener required by the design. Some hubs use 2 set screws in the same threaded hole or screws positioned 90 degrees apart. Do not round a socket by using the wrong hex key. Keep removed parts labeled by location and do not invent a universal loosening sequence. Prepare the exposed shaft before the hub passes over it. Remove loose rust and dirt, then inspect for mushrooming, raised burrs, scoring or a damaged keyway. Correct minor burrs only by the procedure permitted for that shaft, and keep debris out of bearings and motor openings. Use penetrating fluid only when compatible with the equipment, materials, and contamination rules. Protect threads and the shaft center from the puller spindle. Choose a tool that loads the hub, not the blades. A manufacturer-approved wheel puller, hub puller, separator, or press fixture should engage a strong hub flange or structural backplate. Puller arms must be symmetrical and the spindle must meet the shaft on center. Thin blades, balance clips, and unsupported side plates are not pull points. Self-centering pullers distribute force more evenly and reduce the damage risk from an off-axis load. Apply a smooth axial pull while watching 4 indicators: spindle centering, equal arm engagement, hub movement, and wheel distortion. Stop immediately if the wheel tilts, a side plate dishes, a jaw slips, the required force jumps, or the shaft begins moving with the wheel. Reassess the hidden fastener, corrosion, burr, and tool capacity. Do not add impact with a hammer, wedge between the wheel and housing, or use uncontrolled torch heat. After removal, inspect the bore, hub, key, shaft, fastener threads, blades, welds, and balance features. A cracked hub, distorted plate, loose blade, or damaged balance weight is not corrected by reinstalling it. Clean mating surfaces and use lubricant or anti-seize only if the equipment instructions allow it. Reinstall to the recorded datum, restore the specified key or bushing arrangement, and tighten fasteners to the exact documented torque and sequence. Finish by proving geometry and operation. With energy isolated, rotate the wheel by hand through a full revolution and confirm stable radial clearance, inlet overlap, centering and no rubbing or wobble. Restore guards and panels, then conduct the manufacturer's controlled startup. Verify rotation, sound, vibration, motor current and delivered airflow. Record the before and after geometry and measured duty. For help matching a blower wheel, hub, shaft and operating point, send Longwell the equipment plate, dimensions and application data.